Welcome to the video on problem 73, parts B, C, and D. It's asking in part B, what is the domain of the function? And remember, we found that the function had an equation of v equals 108x squared minus 4x cubed. That was shown in the last video. But we had this really important constraint where y had to equal 108 minus 4x, okay? And the domain is talking about all of the x values that are allowed in the function. So before we can figure out what x values are allowed in the function, we have to make sure that this constraint is taken into account, okay? So if I sort of use my common sense and I think about what x values make sense, even if I look at the picture, right? If I think about it, the lowest that x could possibly be would be 0. And theoretically, having x equals 0 would mean that you really would have a flat surface, you know, or you wouldn't even be able to see it. So, I mean, the lowest we could possibly go for x would be 0. So I'm going to go ahead and put 0 in interval notation with a closed bracket. Okay. Now, what is the biggest x value that makes sense? Don't forget, I can't violate this constraint. At all times, the y has to equal 108 minus 4x. So if I think about it, how do I get this number to make sense? If I think that y can't go any lower than 0, right? It can't go any lower than 0. And I set 0 equal to negative 4x, and I solve for x, okay? I will get that 4x equals 108, or that x equals, what is that, 27? Is that right? Yeah, 4, yep, okay. X is 27. So if x were as big as 27, right, then y would be 0, and we can't have y being any smaller than 0. So I'm gonna say that the domain is between 0 and 27 inclusive, okay? If x is 27, that would make the length 0, which is as small as the length could be. But if you think about it, if x is less than 27, like, I don't know, let's say x is, 10 or something, then 108 minus 40 would be a positive length, okay? So the correct answer here is that the domain is from 0 to 27 inclusive, if you can assume and believe that y and x are technically allowed to be 0. Now, part C, I think we're going to skip this. Part C asks you to use a graphing utility to graph the function, and you can use Desmos for this. When I tried to graph this function on Desmos, because the numbers are so big, it's just really hard to see. So, I mean, you can try it, but I'm not really interested that you do that part of it. So we can just say we'll skip this part. You can try that on your own if you want. And in terms of what dimensions will maximize the volume, well, I have to think about what is going to make the volume be the greatest. Okay, now, in theory, here's our function. And I need to think about what x value maximizes the volume, okay? So one way I could do this, and we don't really know enough calculus yet, is to find the derivative of this function, set the derivative equal to 0, because that's where the rate of change would be the highest, and then solve for those particular x values, okay? Instead of doing that, I'm going to show you in the next video a more common sense approach that may be more intuitive. So stay tuned for this answer.